Ensemble learning helps to improve machine learning model performance by combining several models. This approach allows the production of better predictive performance compared to a single model. Bagging is an ensemble learning technique which applies bootstrapping to machine learning. Bagging is also known as bootstrap aggregating. So, you may ask, what is bootstrapping? Bootstrapping is a statistical technique that creates multiple datasets by sampling data with replacement. Suppose you have a dataset. Instead of using the same training dataset, you draw bootstrap samples from the initial training dataset. For each bootstrap samples, you fit a Bayes estimator. This technique can be used as a way to reduce the variance of a Bayes estimator. So, you can use the overcome overfitting problem with bagging estimator. Now, I'm gonna show you how to implement bagging classifier using scikit-learn with a real-world dataset. Before loading the dataset, let me import pandas. Import pandas spd. To show how to implement the bagging classifier, I'm gonna use the Breast-Cancer Wisconsin dataset. Let's load the dataset. df equals pd.read csv. Let me set the dataset name wdbc.data. This dataset has no column name. Let me use header equals none. Cool! Our dataset loaded. You can find the link for this dataset in the description below. Let's take a look at the first 5 rows of the dataset. df heat. Here you go. This dataset consists of example of malignant and benign tumor cells. The first column is the dataset shows the unique ID numbers, and the second column shows diagnosis. Let's say M indicates malignant and B indicates benign. The rest of the columns are our features. Let's take a look at the shape of the dataset. df.shape. You can see number of the rows and the columns. Now, let's create the input and output variables. To do this, I'm gonna use the log method. First, let's assign the features to a numpy array. X equals df.log colon comma 2 colon. To convert a numpy array, let me set values. Okay, now let me create the target variable. Y equals df.log colon comma 1 values. Beautiful. We have created the variables. Our target variable has 2 categories, M and B. Let's encode the target variable with label encoder. First, I'm gonna import this class from sklearn.preprocessing import label encoder. Now, I'm gonna create an object from this class. le equals label encoder. Let's feed and transform our target variable. Y equals le.feed transform. Let me set y. Awesome! We encoded target labels. Before building the model, let's split the dataset into training and test sets. To do this, I am gonna use the train test split function. First, let me import this function from sklearn.model selection import train test split. Let's split our dataset using this function. X train x test y train y test equals train test split. Let me set the variables x, y. To split imbalanced, let me set stratify equals y. For reproducible output, let me set random state equal 0. Cool! Our dataset are ready to analyze. Now, I'm gonna use the bagging technique to analyze data with scikit-learn. First, let me import bagging classifier from the ensemble submodule from sklearn.ensemble import bagging classifier. I'm gonna use decision tree classifier as a Bayes estimator. Let me import this class from sklearn.tree import decision tree classifier. Beautiful! Our classes are ready. First, I'm gonna boot the model with decision tree classifier. After that, I'm gonna use bagging to boot the model. Lastly, I'm gonna compare these models. Let's create an object from decision tree classifier class. Tree equals decision tree classifier. Now, let's fit the model using this object. Tree equals tree dot fit x train y train. Cool! The model is built. Now, let's predict the training set. Y train pred equals 3.predict x train. Next, let's predict the test set. Y test pred equals tree dot predict x test. Now let's see the performance of the model and the training and test set. To do this, I'm gonna use accuracy score function. Let me import this function from sklearn dot matrix import accuracy score. Now let's take a look at the accuracy score of the training set. Tree train equals accuracy score. Let me set ytrain pret. After that, let's see the accuracy score of the test set. Tree test equals accuracy score ytest pret. Beautiful. We calculate the accuracy scores. Now let's print these scores. Print f quotation marks decision tree train test accuracies. I'm gonna write curly brackets tree train dot tree f slash curly brackets tree test dot tree f. Here you go. The score of the tree model on the training set is 100%, but the score of the tree model on the test set is 94%. Note that lower test accuracy indicates high variance of the model. In other words, there is an overfitting problem in tree model. Now let's build a bagging model. To do this, let me create an object from bagging classifier. Bag equals bagging classifier. Let's write the base estimator to fit on random subset of the dataset. Base estimator equals 3. Let me specify an estimator's parameter. An estimator, let's say 100. For random state parameter, random state 0. Awesome. Our object is ready to train. Let's fit the bagging model using the training set. Bag equals bag dot fit xtrain ytrain. Cool. The model is built. Now let's predict the training set using this model. Ytrain pred equals bag dot let me call predict xtrain. Next, let's predict the test set. Y test pred equals bag dot predict x test. Now let's see the performance of the model on the training and test set. To do this, I'm gonna use accuracy score function again. First, let's take a look at the accuracy score of the model on the training set. Bag train equals accuracy score ytrain pred. After that, let's see the accuracy score of the model on the test set. Bag test equals accuracy score ytest pred. Beautiful. We calculate the accuracy scores. Now let's print these scores. Print f quotation marks bagging train test accuracies curly brackets bag train colon dot tree f slash curly brackets bag test dot tree f. Here you go. The score of the bagging model on the training set is 100%, but the score of the bagging model on the test set is 96%. When comparing the bagging model with the tree model, I can say that the bagging classifier has a slightly better generalization performance. In summary, bagging is a simple and very powerful ensemble method. The idea behind bagging is combining the result of multiple models to get a generalized result. You can use bagging to reduce the variance of your model, but bagging is ineffective in reducing model bias. That's it. I hope you enjoyed. In this video, I talk about bagging. You can find the link for this notebook in the description below. Thanks for watching. Don't forget to subscribe to my channel, give a like and leave a comment. See you in the next video. Bye for now.